So 5.4 today we're going to cover squares and trapezoids. We're going to know the characteristics of squares and trapezoids. A square is a quadrilateral with all sides congruent and 4 right angles. A square is therefore a rhombus because of all the sides being congruent, and it's a rectangle because of the 4 right angles. Because of A and B, a square is also a parallelogram. Squares and rectangles and rhombuses are parallelograms, so a square is one. There are alternate definitions for a square. And then isosceles trapezoid. An isosceles trapezoid is a quadrilateral with exactly one pair of parallel sides and congruent legs. Parallel sides, congruent legs. The legs are the non-parallel sides. The base angles of an isosceles trapezoid are congruent. You've got two pairs of base angles, each one touching the parallel line. So A and D are a pair of base angles, and B and C are a pair of base angles. We're going to prove this theorem. Okay, this proof is kind of tricky. We'll just talk through it. Okay, so we have an isosceles trapezoid with AD. AD is parallel to BC, and we have AB congruent to BC. So to prove this, we're going to draw a segment through C parallel to AB to form a parallelogram and a triangle. So here's the proof. We would let CE be parallel to AB. So we've got CE parallel to AB. And then ABC is a parallelogram because it's a parallelogram because the opposite sides are parallel. So then we could say that AB is the same length as CE, right? And CE would be the same length as CD because AB also equals CD. So we've got these two congruent. CE and CD are congruent. So then that makes this this triangle an isosceles triangle. So its base angles are congruent. So this angle is the same as that. And because that CED we know that angle A, because it was an isosceles trapezoid, we knew A was congruent to D, right? And then it follows, since AD is parallel to BC, it follows that angle B and angle C angle B would be supplementary to A, and C would be supplementary to D. Since they're both supplementary to congruent angles, they would be congruent. So there we have an isosceles trapezoid. Alright. Now I'm not going to make you do one like that on the quiz or the test, but that's just to show you a way you could prove that through adding that additional line. Trapezoid ABCD is isosceles. Find the angle measure of X. How could we do that? Chris? Okay, so what would the last angle be, Chris? Yeah. 1670 is 130, subtract that from 180, so it would be 50. That's 50. Where do we do from there, Shatis?
So since the base angles are congruent, angle D would be congruent to the whole measure of angle A, and since they both have to be 70, 70 minus 50 would be 20, so X is 20.
Okay, yeah. Since this is an isosceles triangle, the base angles are congruent, so we could say x plus 50 equals 70. And so then we have x equals 20 degrees. Any questions there? Okay, good. Theorem 531 says if the base angles of a trapezoid are congruent, then it is isosceles. So now we have the opposite situation. We've got congruent base angles. We've got to show that the AB is equal to CD. So here's how we'll do an informal proof. Well, no, we're not going to prove the theorem. We're going to do this proof. In an isosceles trapezoid, AB, CD. AB is parallel to EH and CD is parallel to FG. We have to prove that EF, GH is an isosceles trapezoid. The inner trapezoid, we have to prove that it is isosceles. We know the outer one is. Alright, so here's how we could prove this. We could say EF, GH is a trapezoid because EF is parallel to GH and EH and FG are not parallel. All right. Angle A is equal to angle D. We know that because it's an isosceles trapezoid. Because AB is parallel to EH and angle A is congruent to EH. Because the A and B are AB and EH are parallel, we have corresponding angles, right? Angle A is going to be congruent to angle EHG. These angles correspond, so those two angles are congruent. And then we can do the same thing on the other side. And CD is parallel to FG, implies that angle D is congruent to angle FGH. Alright, so now we have these two angles congruent. And now, by transitive, since angle A is congruent to angle D, we can say angle EHG is congruent to angle FGH. So we can say EFGH is isosceles because of that theorem we just had. The base, because its base angles are congruent. Base angles of a trap are congruent. All right. Questions on the proof? I might put one like that on the test. I don't know. Yeah.
Could we have proven that it was an isosceles trapezoid by doing the opposite by saying B and C were congruent? Using the same thing?
Yeah, up at the top. Yeah, you could have done the same thing at the top. Yes, that's correct. Yeah. All right. So then, in your last page of notes, you've got this chart. Okay. I'm not going to take the time to talk through that entire chart. But what I would do before the test is I'd cover up the X's and I'd test myself. I'd do parallelogram. Do the diagonals form congruent triangles, and that's yes, it has an X. So, and then I do both pairs of opposite sides congruent in a parallelogram. Yes, and I see which ones applied, and then then we could go diagonals are congruent in a parallelogram. We know that's no. Right. So in your mind, I would go through this, and I'd match up the characteristics with the shape. Sort of quiz yourself. That's a good way to review all these characteristics. That's a big thing to remember in this chapter. Really, is if you know the characteristics, then you can probably do the problems. The problems aren't that difficult of math, but you got to know the characteristics to apply. Any questions on that? All right.